Have you ever looked up at the night sky and felt a profound sense of loneliness, a feeling that in all this silent, sprawling blackness, we are utterly and completely alone? What if I told you that right now, as you're reading this, that fundamental assumption is being challenged in the most dramatic way imaginable? Something is happening just beyond our sight. A clandestine encounter of cosmic proportions that could rewrite everything we thought we knew about our place in the universe. Hidden behind the blinding glare of our own sun, an object forged in a star system that died billions of years before Earth was even born, is currently weathering a storm of solar fury. This isn't a hypothetical scenario from a science fiction novel. This is happening. This is 3I Atlas, the third interstellar visitor ever confirmed, and it has just become the focal point of an unprecedented and perhaps slightly panicked global alert. NASA has officially activated its planetary defense protocols, not for a rock threatening to hit us, but for a messenger from the void that is simply passing by. The question we have to ask is, why? What are they so afraid of? Let's delve into the story of what's unfolding right now, 200 million kilometers away on the far side of our star. Imagine the sun not as the gentle, life-giving orb we see every day, but as a seething, violent beast of nuclear fusion. On its surface, magnetic field lines, trillions of times more powerful than Earth's, twist and snap like colossal rubber bands. When they break, they unleash energy on a scale that dwarfs our entire nuclear arsenal. On October 23, 2025, this is precisely what happened. But this time, it was different. It happened on the far side of the sun, the hemisphere turned away from us, a place we can only monitor with a handful of specialized probes. Russian astronomers at the Laboratory of Solar Astronomy, a dedicated institution, a part of the Lebedev Physical Institute, and Izmiran, were the first to see the signs. Sifting through the data from their instruments, which monitored the sun's corona and solar wind, they detected the telltale shockwaves of a monstrous explosion. They estimated its power at X10 class, maybe even higher. To put that into perspective, let's break down the classification system. Solar flares are categorized by their intensity, with A, B, and C classes being relatively minor. M-class flares are significant and can cause brief radio blackouts on Earth. X-class flares are the titans, the most intense category we have. An X1 flare is already a major event. An X10 flare, therefore, is 10 times more powerful than that, a cataclysmic blast. Think of the most powerful volcanic eruption in human history, the 1815 eruption of Mount Tambora, which plunged the world into the year without a summer. An X10 flare releases energy equivalent to 1 billion of those eruptions, all in the span of a few minutes. This explosion didn't just release light and radiation, it triggered what's known as a coronal mass ejection, or CME. This is the real heavyweight in this encounter. The blast hurled a cloud of over 1 billion tons of superheated plasma, a chaotic soup of charged protons and electrons, out into space. This solar tsunami was traveling at a staggering 2 million kilometers per hour. Here's where this story shifts from a routine astronomical event to something unprecedented. CMEs happen all the time. Usually, we're only concerned when they're aimed at Earth, as they can cripple our satellites, destabilize power grids, and pose a danger to astronauts. The famous Carrington event of 1859, a massive solar storm that struck Earth, was so powerful it set telegraph offices on fire and created auroras visible as far south as the Caribbean. A similar event today would be catastrophic, causing trillions of dollars in damage and potentially knocking out our infrastructure for years. You can learn more about its potential impact by looking up the 2012 solar storm that narrowly missed Earth. But this CME wasn't aimed at us. It was heading out into the empty space of the solar system. Except it wasn't empty. With chilling accuracy, the trajectory of this plasma cloud was calculated to be within a 10 to 20 degree cone pointed directly at the predicted location of 3I Atlas. The timing was almost supernatural. The astronomers calculated the moment of impact, approximately 3 p.m. Moscow time, October 24, 2025. At that precise moment, the ancient interstellar comet would fly directly into this wall of energized particles. The calculations further showed that due to the sheer size of the CME, the comet would remain engulfed within it for at least 36 to 48 hours. Think about that. A solar explosion of historic proportions occurs at the exact time and in the exact direction to intercept this specific interstellar visitor, all while the object is conveniently hidden from every single one of our prying eyes. In their official report, the Russian scientists, perhaps with a touch of gallows humor, reportedly joked, "Let's see how the aliens handle being weather sensitive." It's a dark joke, but it touches on a raw nerve. In H.G. Wells's classic The War of the Worlds, the technologically superior Martian invaders were ultimately defeated not by human weapons, but by the humblest of Earth's organisms, common bacteria. Nature, in its own way, defended the planet. Now our own star was unleashing a natural tempest upon this visitor. Whether you believe 3I Atlas is an alien probe or just a very, very old comet, something extraordinary and strange is happening. An object that is potentially 7 to 10 billion years old, an object that may have witnessed the birth of our galaxy, is being sandblasted by a torrent of charged particles. What could this do? Will it simply erode the surface? Could it trigger a massive release of internal gases, causing it to brighten spectacularly? Could the electromagnetic shock wave activate something within it? Or could the intense forces rip the fragile object apart? We have absolutely no idea. And it is this profound uncertainty that pushed NASA to do something it has never done before. On October 23rd, NASA, in coordination with the International Asteroid Warning Network, IAWN, officially activated a planetary defense observation campaign. The IAWN is a global collaboration of observatories and space agencies, including NASA and the European Space Agency, ESA, designed to detect, track, and characterize potentially hazardous near-Earth objects. Their job is to protect us from asteroid impacts. But 3I Atlas poses zero threat to Earth. Its trajectory doesn't bring it anywhere near us. So why activate a defense protocol? The official announcement was a masterpiece of carefully worded bureaucracy, speaking of the unique challenges the object presents and the opportunity to conduct global exercises. But when you read between the lines, the message is clear. This is the first time in human history that Earth's planetary early warning system has been formally mobilized for an object that came from another star. To understand the full weight of this decision, we have to go back to the beginning. It was July 1, 2025. The Atlas telescope system, a pair of robotic observatories in Hawaii and Chile, was doing what it does every night, scanning the sky. ATLAS stands for Asteroid Terrestrial Impact Last Alert System. Its mission is in its name, to find dangerous asteroids with enough warning time to do something about them. It spotted a new, faint object. Initially, nothing seemed out of the ordinary, but within hours, as observatories around the world confirmed the sighting and began to calculate its orbit, a buzz of excitement and disbelief spread through the astronomical community. The object's trajectory wasn't an ellipse, the closed loop of an object gravitationally bound to our Sun. It was a perfect hyperbola. This mathematical signature is an unambiguous smoking gun. The object was moving too fast to be captured by the Sun's gravity. It had fallen into our solar system from interstellar space, and it would eventually be flung back out, continuing its journey into the void. This was only the third such visitor ever confirmed. The first, Oumuamua, which whipped through our system in 2017, shattered our preconceptions. It was bizarrely shaped, like a cigar or a flat pancake, and it showed no signs of outgassing, no coma or tail. yet it accelerated away from the Sun as if something were gently pushing it. The second 2I Borisov, discovered in 2019, was almost reassuringly normal. It looked and behaved like a typical comet from our own solar system, just with a slightly different chemical makeup. And now we have 3I Atlas. And this one is different from both of its predecessors in almost every conceivable way. First, there is its sheer size. Initial estimates, based on its brightness and the amount of gas it's producing, place its solid nucleus, the core of rock and ice, at somewhere between 2 and 6 kilometers in diameter. To help you visualize that, Mount McKinley, Denali, the tallest peak in North America, is about 6 kilometers high. Imagine that mountain, compressed into a rough sphere, made of ancient ice and rock, with a total mass estimated at 30 billion tons. Now imagine that mountain hurtling through our solar system at 210,000 kilometers per hour. But its size isn't the most baffling part. It's its behavior. By all the laws of cometary physics we understand, 3I Atlas should be completely dormant. It's currently about 3 astronomical units, AU, from the Sun. 1 AU is the distance from the Earth to the Sun, about 150 million kilometers. 3 AU puts it roughly in the main asteroid belt between Mars and Jupiter. At that range, the Sun's warmth is feeble. There simply isn't enough solar energy to cause water ice, the primary component of most comets, to sublimate or turn directly from a solid into a gas. Typically, comets don't wake up and form their characteristic coma and tail until they get inside 2 AU. But 3I Atlas is wide awake. It is actively producing water vapor at a rate of 40 kilograms per second. That is the equivalent of filling a large bathtub with water every single second, continuously. How is this possible? Comets are inert. They don't have internal engines or geological activity like planets. They are essentially giant, frozen snowballs. So what's generating the heat needed to vaporize so much ice at such a great distance? This question has sent theorists scrambling, and they've come up with a few possibilities. Maybe the comet is exceptionally rich in highly volatile substances like frozen carbon monoxide, CO, or carbon dioxide, CO2, which turn to gas at much colder temperatures than water. The sublimation of these super volatiles could be energetic enough to drag water ice particles with them. Another theory is that some kind of exotic chemical reaction is happening deep inside the nucleus, perhaps involving amorphous ice, a disorganized, glassy form of water ice that can release a burst of energy when it crystallizes. A third idea is that the object's ancient journey has riddled it with structural cracks. As it warms ever so slightly, these cracks could expose vast new surfaces of pristine ice to the faint sunlight, dramatically increasing its activity. Or perhaps millions of years ago, it passed close to another star, absorbing a tremendous amount of heat that it is still slowly releasing from its core. Each of these theories is plausible, but none of them fully explains the observations. And this leads to the most radical theory of all, the one most scientists are hesitant to even whisper. Maybe it's not a comet. This suggestion comes from a name you might recognize. Avi Loeb, the Harvard astrophysicist who became famous, or infamous, depending on your perspective, for his bold hypothesis that Oumuamua might have been an alien probe. Loeb has been studying 3I Atlas with intense focus, and he argues that the accumulation of anomalies points away from a natural explanation. He highlights the perfectly timed trajectory, the unusual chemistry, the water production anomaly, and something else that has been quietly debated among orbital dynamicists: the object's acceleration. When comets outgas, the venting material acts like a tiny chaotic rocket engine. This is known as non-gravitational acceleration, and it's completely normal. But these natural jets are unpredictable. They sputter and flare up as different pockets of ice are exposed to the sun. This makes the comet's path wobble and deviate from a purely gravitational orbit in a messy, chaotic way. 3I Atlas's acceleration pattern is different. It's too smooth, too consistent. It's as if the thrust is being applied in a controlled, steady manner. Loeb suggests this is evidence of something far more deliberate. He proposes that the object might be using a technique known as an Oberth maneuver. This is a very real principle of orbital mechanics that NASA uses for all its interplanetary missions. The concept is simple, but brilliant. You get the biggest bang for your buck from your rocket engine when you are moving at your fastest. Think of being on a swing. If you want to go higher, you don't kick your legs at the top of the arc where you're moving slowest. You pump them at the very bottom, at your point of maximum velocity. The same principle applies in space. By firing an engine at perihelion, its closest and fastest point in an orbit around a massive body like the Sun, a spacecraft can achieve a much greater change in its energy and trajectory than if it fired the engine anywhere else. It's the ultimate fuel efficiency technique. Loeb's suggestion is that 3I Atlas may have executed a subtle Oberth maneuver as it rounded the Sun, using some form of controlled propulsion to fine-tune its path. Natural comets don't plan their outgassing for maximum orbital efficiency. A probe, however, absolutely would. And what a path it is! The trajectory appears almost purpose-built for a reconnaissance mission. On October 3rd, it made its closest approach to Mars, passing just over 20 million kilometers away, close enough to fly through the planet's extended magnetosphere. In early 2026, it's scheduled for a flyby of Venus. Later that year, it will pass by Jupiter. It's a grand tour of the solar system's major inner worlds. What are the odds of that happening by chance? While planetary alignments are common, the precision and sequence are interesting. It ISS as if it was designed to get a good look at each of the most promising planets in our system. Then there is the timing of its disappearance. 3I Atlas is currently behind the Sun from our point of view, a period astronomers call solar conjunction. It will remain hidden there until mid-November. The comet entered this observational blind spot at almost the exact moment the CME was set to hit it. So, whatever is happening to it right now, whether it's breaking up, activating, or simply getting a cosmic car wash, is happening in complete privacy. We have no direct way to observe it. The Solar Orbiter, a joint ESA-NASA probe, can see parts of the Sun's far side, but its current position in orbit doesn't give it a view of the right location. For the next several weeks, we are completely blind. And that is why the global observation campaign is being planned with such urgency. Everyone wants to be ready the second it reappears, to see what, if anything, has changed. What truly sets 3I Atlas apart, what makes it arguably the most scientifically valuable object ever detected in our solar system, isn't just its behavior, but what it's made of and when it was made. When the James Webb Space Telescope, JWST, turned its powerful infrared eyes on the object back in September, the data it sent back was stunning. JWST is equipped with incredibly sensitive spectrographs. Spectroscopy is the science of breaking down light into its component colors, or spectrum. Every element and molecule absorbs and emits light at specific, unique wavelengths, creating a chemical fingerprint. By analyzing the light from 3I Atlas's coma, scientists can determine exactly what gases it's made of. Comets in our own solar system have a fairly consistent recipe. Lots of water ice, with smaller amounts of carbon dioxide, carbon monoxide, methane, and ammonia. The ratios vary, but water is almost always the dominant ingredient. 3I Atlas throws that recipe out the window. It is producing carbon dioxide, CO2, at 8 times the rate of water vapor, a ratio of 8.1. This isn't a minor variation. It's a fundamentally different kind of object. In our solar system, even the most CO2-rich comets barely reach a ratio of 2 or 3 to 1. This thing is chemically backward from everything we know. This strange fingerprint tells us a profound story about where this object was born. The specific mix of ices that freeze into a comet depends on the temperature and chemistry of the protoplanetary disk around its young parent star. An object with 8 times more CO2 than water must have formed in a very specific and alien environment, a region that was simultaneously hot enough to keep most water as vapor, preventing it from freezing into the comet, but just cold enough for CO2 to condense into ice. Scientists have described this environment as baked and boiled. It suggests 3I Atlas formed around a star that was perhaps much larger and hotter than our Sun, in a planetary system with a chemical makeup completely unlike our own. But the most mind-bending discovery is its age. By precisely tracking the object's trajectory and running the calculations backward, accounting for the gravitational pull of our galaxy's stars and central black hole, astronomers can trace its path through the Milky Way over eons. The results are staggering. The calculations show that 3I Atlas has been wandering interstellar space for 7 to 10 billion years. Let that number sink in. Our Sun is 4.6 billion years old. The Earth is 4.5 billion years old. This object predates our entire solar system by at least 3 billion years. It is a true relic from the early universe. When this object formed, the Milky Way galaxy itself was still in its turbulent youth. Star formation was happening at a frantic pace, and the chemical composition of the galaxy was different, with fewer heavy elements. The star it originally orbited is almost certainly long dead, having ended its life as a supernova or a fading white dwarf billions of years ago. The solar system that birthed 3I Atlas is gone, lost to time. But the comet remains, a perfectly preserved time capsule. For most of its existence, it has been in a state of cryogenic deep freeze, drifting through the void between stars where temperatures are just a few degrees above absolute zero. In these conditions, chemical reactions stop. The original materials are locked in place, a pristine sample of the chemistry of the ancient galaxy. But this creates a powerful paradox. If it's been frozen for billions of years and battered by cosmic rays on its long journey, why is it so active now? Ancient ice should have its most volatile components stripped away. It should be a dead, inert rock. Instead, it's acting like a fresh, young comet. This leads to an alternative theory. Perhaps 3I Atlas is made of ancient material, but is itself a structurally young object. Imagine a Pluto-sized dwarf planet that formed 10 billion years ago. For eons, it orbited its star, its ancient chemistry preserved deep within its frozen core. Then, relatively recently, perhaps only a few million years ago, a catastrophic event occurred. A collision with another planet, or a close gravitational encounter, shattered this ancient world, sending fragments of its pristine interior flying out into interstellar space. 3I Atlas could be one of those fragments. This would elegantly solve the paradox. Its ingredients are ancient, but the object itself is freshly broken, exposing unprocessed ice to space for the first time. This brings us back to the present moment and the intense anticipation for mid-November. The observation plan that has been put into motion is unlike anything ever attempted for a comet. The moment 3I Atlas clears the sun's glare, the campaign begins. The first priority is to nail down its trajectory with pinpoint precision. Radar facilities like the Green Bank Telescope and the Goldstone Deep Space Communications Complex will ping the object, firing radio waves at it and analyzing the returning echo to get an exact measurement of its distance, velocity, and direction. Any deviation from the predicted path, no matter how small, will be immensely significant. If its new trajectory perfectly matches what we'd expect from the solar wind of the CME pushing on it, that would support the natural comet theory. But if the change in velocity is more consistent with a controlled, efficient Oberth maneuver executed at perihelion, the implications would be staggering. The second priority is spectroscopy. The JWST, the Hubble Space Telescope, and the world's largest ground-based observatories, like the Keck telescopes in Hawaii and the Very Large Telescope in Chile will once again dissect its chemical fingerprint. Has the 8:1 CO2 to water ratio changed? Has the intense energy of the plasma bombardment triggered the release of new, unexpected materials from its interior? They will be looking for anything anomalous, particularly for spectral lines that don't correspond to any known natural molecule. It's a long shot, but embedding a unique artificial chemical signature in an object's outgassing would be a subtle and brilliant way to signal intelligence across the eons. The third priority, and the one that carries the most speculative weight, is the search for radio signals. The Very Large Array in New Mexico, the ALMA array in Chile, and even China's colossal fast telescope will be listening intently. Officially, they are measuring the object's natural thermal emissions. Unofficially, they are conducting the most targeted search for extraterrestrial intelligence in history. They'll be scanning for narrowband signals, repeating patterns, anything that looks like it was artificially generated. The chances are, of course, infinitesimally small, but if you have an object in your own backyard that is behaving this strangely, you have to check. You simply have to. As we wait, we can envision 4 basic scenarios for what we might find, ranging from the mundane to the world-altering. Scenario 1. Everything is normal. The most likely outcome. 3I Atlas reappears, looking a bit battered but behaving in ways that are entirely consistent with a natural comet being hit by a CME. The trajectory changes are predictable, the composition is largely the same, and the radio is silent. We will have learned a tremendous amount about interstellar comets, but the fundamental mystery will be resolved in favor of a natural explanation. Scenario 2. Interesting, but explainable. We find something new and weird. Perhaps the plasma triggered exotic chemical reactions, creating molecules we've never seen in a comet before, but which our chemists can explain. Perhaps the object is fractured, changing its outgassing pattern in complex ways. It would still be a major scientific discovery, fueling years of research, but it wouldn't be evidence of alien technology. Scenario 3. Unexplained but inconclusive. This is the most frustrating and perhaps the most likely of the strange outcomes. The data is deeply weird. The trajectory has changed in ways our models can't account for. The spectroscopy shows elements that have no business being there. We might even detect a brief structured radio pulse that never repeats. We would have a genuine, undeniable anomaly, but no smoking gun. The scientific community would be torn apart by debate. It would be Oumuamua all over again, but 100 times more intense. We would be left with a tantalizing, maddening mystery as 3I Atlas sails away, forever beyond our reach. Scenario 4. Unambiguous evidence. The discovery that would change the world forever. The object alters its course in a way that can only be explained by controlled propulsion. It transmits a clear, structured signal containing mathematical constants like pi. Its spectroscopic signature shows processed, artificial elements. In this scenario, the debate ends. The scientific consensus shifts from probably natural to undeniably artificial. Humanity would be forced to confront the staggering reality that we are not alone, and that an artifact from a civilization, potentially billions of years our senior, has just passed through our home. The philosophical, social, and religious implications would be overwhelming. We would have to ask ourselves, what do we do now? Regardless of which scenario unfolds in the coming weeks, we are living through a remarkable moment. The fact that we can even have this conversation, that we possess the technology to detect these messengers from other stars and analyze their secrets, is a testament to human ingenuity. For all of history, the question, "Are we alone?" was a matter of pure speculation. Now it is a testable hypothesis. 3I Atlas has already given us a profound gift. It has forced us to confront the sheer diversity of the cosmos, to accept that our own solar system may not be the norm, but just one strange possibility among trillions. It has reminded us that the universe is far more complex, ancient, and mysterious than we can possibly imagine. The lesson here, the wisdom we can draw from this cosmic drama and apply to our own lives, is the profound power of curiosity and the importance of questioning our most fundamental assumptions. For centuries, we assumed objects in our solar system were from our solar system. That assumption is now broken. What other assumptions are we making in science and in our daily lives that might be holding us back from a deeper understanding of the world and ourselves? This story teaches us to embrace the unknown, to look at anomalies not as problems to be dismissed, but as opportunities for discovery. It's about following the evidence wherever it leads, even if it leads to uncomfortable or world-shattering conclusions. So, as we wait for 3i Atlas to emerge from its hiding place, I want you to think about these questions. What would it truly mean for your life, for your beliefs, if we found definitive proof that other intelligence exists in the universe? Would it be terrifying, or would it be inspiring? And if it turns out to be just a weird comet, does that diminish the wonder, or does it enhance it by showing us just how strange and beautiful nature can be on its own terms? Whatever we find, we will have learned something amazing. We cannot lose, and that is the beauty of science and exploration. It is the journey, the asking of the question, that enriches us. I hope this story has sparked your curiosity and filled you with a sense of wonder about the incredible universe we inhabit. Thank you for joining me on this journey. I wish you all clear skies and curious minds. If you found this story as fascinating as I do, please consider subscribing to the channel for more deep dives into the mysteries of our cosmos. We will be following the 3i Atlas story closely, and will bring you updates the moment they become available. Until next time, keep looking up.